Unit 5, that is mechanical properties and deformation of metal. In this chapter, we are going to discuss the capacity of the material is blow without fracture is known as impact strength or impact resistance. It is used to perform the behavior of materials to study the dynamic load that can be applied very fastly. It indicates the toughness of the material to absorb the energy during the deformation of plastic. Toughness to measure the both strength and ductility. It has two types. First one is ISAT impact test and Charpy impact. Diagram of Charpy and ISAT test impact test. Well, in the center, this is a Charpy. While the hammer is start position while using that in physics oscillation, it can be cut the specimen with end of the anvil. The specimen size should be 10 cross 10 into 75 mm. The pendulum will cut the and piece that square to accurate that. The procedure is shown here. It consists of breaking the specimen by blowing a swing hammer under the specified condition. The blow is struck at fixed position on the face having a notch. When the striker impact specimen will absorb till yields. At this point, the specimen will begin to undergo the plastic deformation and also absorbs the energy with work hardened to plastic zone to when the energy has no energy to fracture takes place for the specimen. The comparison of ISAT impact test with Charpy impact test. While the material tested the plastic metals and plastic, while the Charpy has metal, the position of specimen have in ISAT that is vertical, in Charpy that is horizontal. The notch type will be ISAT for V notch and Charpy V notch and U notch. The notch face direction in front of striker that is away from the striker. The types of striker, farming hammer and ball pin hammer. The size of the specimen is 75 mm into 10 mm into 10. While it is Charpy, the 55 into 10 into 10 mm. The striking point upper tip, while Charpy is center of specimen. Next one is fatigue test. The fatigue test is used to apply alternative loading of specimen. While the working takes place as the test specimen is placed in the machine, you are going to see in that picture and the specimen is placed in the machine. While the steady blending is applied for shaft, the electric power is applied. Then the resolution thunder is used to measure the number of rotation. It is used the collet lever and specimen is the tension and compressive we have seen. An alternate number of cycles in stresses is equal to the number of rotations. The test is performed various cycles. From this fatigue curve shows the experiment graph is shown. This remains constant while the degrees of number of next one, creep test, that is creep failure mechanism. The, the continuous deformation of metals undergo steady load is known as creep. When the material is subject to load, higher temperature along the period. The factors affect creep, the grain size, thermal stability of microstructure, chemical reaction, shear strain. Procedure: the specimen is subject to constant load by the means of death weight. A tubular electrically heated furnace surrounds the measurement of temperature at maintain constant temperature with thermocouple. While the total creep elongation to measure the extremometer and percentage of elongation is plotted against it. The picture shown that there's a, while the lower pulley is moving up, the specimen is placing in the center part of the furnace. It is the knife edge is loading the curve with universal coupling, and therefore the loading leaves moving and knife edge will be loading the weight. The mechanism of creep failure has three stages, that is primary, secondary and tertiary. While the primary occurs at beginning of the test and secondary it is the rate of becomes roughly steady. In tertiary it will increase the time to fact under the fracture occurs. The, the creep curve is a while the strain on y-axis and time is in x-axis. The initial load will be the taking place while the three stages are kept. The elongation, the fracture is appears in third stage. That's all. Thank you.